Okay, Chapter 7. Between subject designs generally is in contrast to within subject designs. Between subject designs are ones in which each person is only in one condition. So if you have two groups, it's one group of people, and then in the other condition, it's another whole separate group of people. And within subject designs, it could be the same people, like a before test and after test. Same person has two scores. And in general, when you have an experiment and you have two groups, you're comparing two scores that are not exactly the same. But even if you had one group of people, they did this test where they remembered a bunch of words and they get score X. Well, if you could take that back and say, have that same group of people 2 days later, and still the first time they're seeing the experiment, and they have the same group of words, it's a different day. You wouldn't probably expect to get exactly the same number of words remembered by all these people, because some would be tireder on one day than another. Some might have seen some of the words right before the test, just in things they're reading, and they stand out more to them now in the test. They might not have stood out to them 2 days ago if they were reading then. And so you just have to expect a certain amount of variability from even the same group of people. So now if you had one large group and you randomly selected into two groups, then you have to think, well, they're pretty closely like the same group of people. But even if we treat them exactly the same, we wouldn't really expect them to both get exactly the same number of words. And so then you have to decide how big a difference is a big difference. If you did something to them, you made the light a lot brighter for one group, and you want to see if that makes them better, and they happen to get a few more words better, you have to decide, is it because I made the lights brighter, or is it because there's just the chance variation on that day? And so you have to compare to something, compare a one group to something else. And usually we think kind of for simple experiment, control group, experimental group. In the example in the chapter, they had 5 dead kids, which immediately was supposed to sound, well, really bad, 5 dead kids. However, you have to consider how many kids there were and consider the fact that in any group of people, a certain number of them die over a period of time. So you look at this pool of dead kids, this pool of kids from which 5 died, and then compare them to all the kids or a larger group of kids. And so you look at wards of the state and people who are not wards, people who are with their original guardians, and then ones that died and ones that didn't die for each of those 2 categories. So 4 sets, 4 cells. And then you can look at percentages, but like I was saying with having people remember words, they're probably not going to be exactly the same. So you have to decide how big a difference is a big difference. Big kind of being a word for important difference or relevant difference. So in the book, there was a really big difference in sample size. The wards of the state, there was 500 of them. In the other non-wards sample, there was 500,000. And then you have the means from each one. And means are generally considered, for most purposes, the best one-number description of the data. You will sometimes see medians on things like prices of houses and things like that, in that when you get to the really expensive houses of people that pay $20 million for their house, that kind of throws the calculation off for some purposes. But most things we consider means to be the best comparison. Then we want to know, is there a difference, an important, significant difference in the death rate between wards of the state and non-wards of the state? And we want to know, if there is this difference related to something, well, is it related to poor care or something other than poor care? And you might wonder, what could there be that would be related to death rate other than some sort of poor care? Well, one thing might just be the people in that are non-wards of the state are healthier to start with. That the people who are wards of the state came from, a certain number of them came from people whose parents died of, say, terminal illnesses or genetically passed on illnesses. So maybe it's not really care either before they became wards of the state or after. It's that a selection process caused them to be less healthy in that group compared to the other. So we're looking for what things we can say about cause and effect, what caused the difference if there is one. And so there's many cases where you can't randomly assign people to groups. In this case, you had people who were wards of the state, people who weren't. You just have to take those the way they are. Like when you do a study about people who did or didn't watch violent TV, it's possible to assign people to watch or not watch violent TV, but basically they do studies on pre-existing levels of TV watching. And Ted Bundy blamed his pornography for his killing of women, sometimes like in the school shootings and students shooting other students. Sometimes they'll look at whether or not they played violent video games, and kind of implying that watching violent video games makes you want to be violent. However, even if the kids who did do the shooting played violent video games and no other kids in school did, you can't necessarily say the violent video games caused them to be violent, because if they already had a predisposition to violence, then that just might make them like violent video games more. Plus, very many people play the same games and don't become violent. And when we look at things like teaching practices, generally people are already in classrooms, they chose their class, or there was really no way to randomly assign people to different conditions. And smoking, there's no way to assign people to smoke and not smoke. And also eating, we pretty much, except for kind of rare occasions, we pretty much cannot control people's eating. So we just have to study them with other self-selected variables that might go with eating or smoking. Before the cigarette companies got really sued by several of the states and made them change their advertising and marketing habits, one of the things they used to say on TV sometimes was, it's never been proven that tobacco causes cancer. It might be the cigarette paper that causes cancer. It's associated whenever people smoke cigarettes. And also, alcohol drinking is highly correlated with smoking, as other risky behaviors might be. So maybe it's actually alcohol that's giving people cancer instead of tobacco. Now, in reality, people don't really believe that, but they were trying to bring up kind of minor experimental flaws in the design flaws, trying to muddy the waters about the nature of their product. And the book does mention the sample size and how the sample size is much larger for the non-ward people, although I would say in this case it's not really a really big problem, in that the small sample is 500. And one of the things about sample size is, with larger sample sizes, you get your estimates of the mean get closer and closer to the true population mean. But with 500, you're already pretty close. So you get kind of diminishing returns for those hundreds of thousands after that. But it is a pretty big difference in sample size. Now, the model experiment, kind of the perfect experiment, you take one group of people, randomize them to two groups, and try to make two identical groups out of them. At least hope you make two identical groups out of them. And then if you have two identical groups, then the only thing different between them is what you do to them, like brighter light, more caffeine, whatever. And so if you do get a difference between the two groups, say with more caffeine, then you can assume that if there's only one difference between the groups, caffeine, no caffeine, and they had a different performance, you cause the performance difference. Now, the book refers to experiment in a more general sense in that it doesn't have to be a two-group randomized type experiment. And so in the example they're using with levels of exercise, the dependent variable was number of 20-minute exercise periods, but this is exercise that they're already doing. So that would represent pre-selected. You can't randomize them in this case. And so basically the two groups become high exercise, low exercise, and then they give everyone a mood questionnaire, and then really they were just using part of the questionnaire, the tiredness scale. And there is kind of a reliability issue based on the fact that when you have smaller numbers of questions, your reliability actually goes down. But anyway, they're just using the tiredness scale. And well, the amount of exercise, what they divided them up on, the tiredness scale part of the mood scores, the actual score, the dependent variable. And so at this point, you should be able to identify, is it between or within an experimental or a quasi-experimental? And so it's between, since you can't be in both high and low exercise groups at once, you can only be in one group. And it's quasi-experimental because you can't actually assign people to this, or at least we didn't in this case. And the book seems to like stem and leaf displays, but there's a lot of different ways you could graph it. Here you can kind of see the bottom of the blue, the thing, this is kind of the blue distribution of scores. The lowest score of the blue ends here, and then there's still two marks here of red below that. And similarly, the highest the red gets here, and there's two marks of blue beyond that. So just another way to look at it. And using the line graph, you see kind of the same thing, although the way it graphed it, it kind of makes the blue run too far down there on 0, but it still kind of shows you blue ending before red. This may be a little better, and that kind of shows the blue pegs there going farther up, the red pegs going farther down. So anyway, this is an easy thing that Excel can do. There's a lot of different graph types, and some simply present the data better than others. And here's an example too of something that you may not notice a lot, although I do after teaching things like this. Now see how big a difference there is between the more exercise, less exercise, 45.4, 54.23. But look at the size of the blue cylinders there. And 45 isn't really, less than half of 54, although the blue thing is less than half. So what makes that look that way is the x-axis has been cut off at 40.